Well, good morning, everybody. When teaching new students about subseasonal to seasonal weather forecasting, we often talk a lot about not overly relying on El Nino or La Nina as the sole predictor for any upcoming season. There's a tendency to do that. We tend to understand it pretty well. We can look at historical correlations and try to back out what we think might happen. But the reality of it is just one of many different factors when it comes to forecasting the weather, longer term especially. There's also one major hurdle that has to be overcome when doing subseasonal to seasonal forecasting at this particular time of year. And that's why I've got you on this article from NOAA. There is a well-researched and well-studied phenomenon called the spring predictability barrier. And it's with specific reference to our inability to accurately capture the way that ENSO events transition. Okay, so that means from El Nino to La Nina, La Nina to El Nino, or any of those going to neutral conditions. And as a result, oftentimes this particular time of year, projections for spring and summer, and even the next winter, have just very low skill. But we're going to do it anyway, because that's what I do in these videos. So let's talk about all of these issues. And we're going to start first with something we've been discussing that we knew was going to happen and finally did over the last couple of days, right? So the last few weeks I've been mentioning we're going to start to see colder water emerge in the equatorial Pacific where El Nino is. And we use this particular animation as our reference point. Where are we? Well, this is the South American side of the Pacific Ocean. This is the Indonesian side of the Pacific Ocean. And this is going down in depth in meters, 450 meters down here. And what we watched since January was this cooler water beginning to upwell and emerge right here at the surface. And it finally did earlier this week, and we can see it right there. So if you remember, we said, hey, there's going to be a change in the ocean temperatures that happens over here first. We actually call this Nino Region 3. All right. And that was almost always where, when an El Nino ends, we start to transition to neutral and La Nina conditions. This is where we begin to see it. Now, I want you to remember something. The ocean temperatures are the last thing to respond. The weather phenomenon, the trade winds have already made their transition away from El Nino-like behavior. The ocean temperatures are the last thing to change. So we just have to keep an eye on it. Now, I'm going to make a hard point throughout, not just now, but probably all the way through our discussions into August. We do have to pay attention to El Nino and La Nina, but it is the complement to El Nino's transition to La Nina and the water temperatures here off the Baja of California and here in the Gulf of Alaska that are extremely important for the Pacific jet stream behavior. It is also the warmth of the North Atlantic, which is still very, very warm, and then this area right in through here we call the main development region, where hurricanes are born later in the season, that is also critical to North American weather. Same thing with the Gulf of Mexico and the Caribbean. So let's not over-attribute to one thing, even though we have to look at it as a major factor. All right, with all of that being said, why are we having this discussion in such earnest at this point in the year? Well, for a lot of my Midwestern farmers, this is the reason why. We've got a strike against us. I mean, there are parts of Iowa that over the last 4 years, primarily because of the negative PDO signals we continue to see, we've had parts of Iowa that are up to 40 to 48 inches below their normal precipitation over 48 months. We have the basin that comprises the Mississippi River, including the Ohio and the Missouri and all the other tributaries, that right now the soil moisture is low. And there's a lot of growers in this area that are quite concerned about what that means going forward. Now, as I always say, that's not to ignore anywhere else, but that is certainly the bullseye in this graphic, as I'm sure you can all see. Now, what about Canada? Canada had incredibly dry conditions. We had it in 21, 22, and last 23 as well. And we can still see up here that underneath some of that snow that just fell, we have some issues as well. The West, we've had a major recovery in moisture. Again, this year, California will spend another year drought-free. We've got decent snows in the Rockies, meaning the upper Colorado Basin's got almost 100% of normal snowpack. And while we still need more here in the northwest United States, I've gotten some reports from some folks, that they're not as concerned as I am about it. Now, Texas, we've already burned 1 million acres. The Southeast has gone back and forth, especially in North Carolina with precipitation and Virginia. In New England, we've been relatively dry for a while. Take a look at this. But I'm not overly concerned about how New England transitions into spring and summer like I am other places. So this map is to complement the previous one, and what it shows you here is since February 1st, where we stand on precipitation ranks by climate district. And your eye is probably drawn to how wet the West has been and how very, very dry we've been right here in the central part of the United States. In fact, some parts of Illinois, Missouri, and Iowa are having, like a top 5 to top 10 driest February and early March on record. The other side of this equation that's got a lot of folks, especially in here, concerned is that we often remember some of our hottest and driest summers following hot and dry springs. And I just know, because I live here, that 2012 was one of the warmest Marches on record. And people are asking me, are we getting back into that scenario? Because you look at these ranks here since February 1st, and you can clearly see the numbers. Out west, we have been picking up a lot of chill hours, but we've been backing off on the ability to get some early heat into the system. We looked yesterday at how there's a pretty sizable deficit in early season accumulation of GDDs, whereas we're way ahead across the eastern 2/3 of the United States. Okay, what's the short of it? Okay, I got another 10 days where this pattern doesn't break. In other words, very mild in the eastern half of North America, very cold in the western half. But that's not going to last for very long. We're going to see this starting to shift pretty quickly once we get the jet stream pattern to do this. By 10 days from now, we start to see this omega look to the pattern. That's going to slow things down, bunch up larger ridges into the west, drive northwest flow after a trough sneaks through into the central United States. That trough's going to go right along the southern tier of the U.S. and join up with a broader trough from the Hudson Bay area. And then we get stuck in middle to end of March, probably the last, I would call it maybe last 10 plus days of March, with ridging west, maybe even some ridging that comes into Greenland, and that just drives colder air in through here. So you say, well, what does that do in terms of precip? Well, that keeps the wettest conditions south, drier conditions, cooler conditions pushing in from northwest flow into the Midwest out of the Canadian Prairie, Northern Plains. And the west, you're going to start accumulating heat. It's going to come in pretty quickly once we get past the middle of March. Now, we want to know how long that is going to last. And so just to give you a quick idea on this, I'm going to show you the newest update. This is from yesterday's run from the European Extended Forecast, which goes out 45 days. And this is how we transition toward the 17th through the 24th of March. Let's go ahead and play it out there all the way to Easter. So this is the last week of March. Much cooler air probably coming in. Now, is this the kind of setup that brings snow, that brings, ice? I don't think so. I just think it's a cooler pattern. Late March sun angles are incredible. So I just see this as cooler conditions, not necessarily as massive Arctic outbreak. But this puts us in a very sensitive position down here, right? Because of how warm things have been as of late, do we end up getting a frost line late into March that sneaks pretty far down to the south? That is still yet to be determined. I think that this begins to break after the first week of April. I think after the first week of April, we warm back up and we see soil temperatures climb back up into the 50s, pretty far to the north. And I have a feeling we're going to make a fast go of planting this upcoming year. And primarily, I think that because of what the precipitation is going to do. Now, I'm going to use the GFS for this. I actually like the GFS solution today a lot. This is what it's got for the next 7 days in terms of precipitation anomalies. We'll come back and revisit this at the end. But this is what it's got for week 2. When that trough dives down, it's wet in the south, southeast. We're drier coming out of the Canadian Prairie. We're drier in the west as the jet stream builds into a huge ridge. And I imagine there's a lot of you out here that are just like, thank God, Eric. Thank you for giving us a different look at the pattern. That's just my imagination. But that's what we're seeing. It's a change. And you say, well, how long does that last? Well, this is the newest outlook from mid-March to mid-April. And what's interesting is, in this particular pattern, the model has kept it wet coming out of the Great Basin through the Four Corners states and into the Central Plains. I'm actually going to be heading over to Manhattan, Kansas tonight. I imagine this is going to be some good news. If this verifies, I'll get to deliver to those Kansas growers. But we see a bit of a drier stripe in through here and drier in the Midwest and upper Midwest. And that's very consistent with an El Nino transitioning to neutral and La Nina. Same thing with the wet conditions in the southeast and up the East Coast. This is also quite common, drier in the Northwest as well. So there's a lot about this upcoming pattern that in the models seem to be responding to the changes in El Nino. And I think we just need to have an in-depth discussion about that. That's why I led this particular video with that idea. So let's get into that. Right now, early in the month, we've kind of got 2 models to compare. Now, you might be saying, well, why don't you show the Canadian model? Why don't you show some of the other ones I don't, because they're so inconsistent. I have a difficult time relying on them and their accuracy. So what I made for you here is the two competing models, one from Europe and one from the US. Now, to be very clear, I have several friends that work for NOAA and the Climate Prediction Center, and they are also very skeptical of their own CFSv2 model. The Europeans are also very skeptical of theirs. That's what good science is, when we take skepticism and use it along with the scientific method to answer questions. Like, that's skepticism alone is a terrible thing. Skepticism combined with the scientific method is how we advance our understanding of the world. So that's what we try to do. So look, the CFSv2, it doesn't just crash El Nino. It has, by July, a strong La Nina, 1.5 degrees C below average. And then by October, a Super Nino. That's where that is. That's that far, Super Nina. Make sure I get my A and O not mixed up. So that's incredible. And the European model says, sure, we're going to let this thing go back into neutral, but possibly by September and October, we're looking at just knocking on the door of La Nina, not full blown into it. Now, some of their models, some of their ensemble members do take it down to 1.5 degrees by September. But my point is that the average of the CFSv2 has 1.5 degrees below average by June in the CFSv2 model. And just to show you the differences, I'm going to take you to the Bureau of Meteorology's website, where they summarize their own forecast. So this is the Australian forecast, the Canadians, the Europeans, the Japanese, the French, the United States, and the British, and then the average. And this is where they all have the March sea surface temperatures in the middle of the equatorial Pacific. And then by July, they have them here. So BOM, the Bureau of Meteorology out of Australia, still has weak and so positive. The ECMWF just made the change, and so did the French. They're almost kind of sitting on the fence. But the Canadians and NOAA are extremely aggressive on going full bore toward La Nina. So what do we do? What do we take away from this? Well, we need to do a comparison, all right? So this is where we are. And I want to make a point behind why we care about this, all right? So what is La Nina? La Nina is actually characterized by the trade wind behavior. It's a change in a circulation called the Walker cell that goes across the open Pacific Ocean, discovered by a man named Sir Gilbert Walker when he was working for the Indian Meteorological Department here back in the 1800s, a long time ago, but that's when he figured it out. So what happens is there's an oscillation in the Walker cell, and when we're in the La Nina stage, which was given to us by Peruvian fishermen, that's where that name comes from, the trade winds are really strong. Let's draw it with a big exaggerated arrow. And what we end up finding is that when that occurs, we get weaker flow in the jet stream level winds here. Now, when you have an El Nino, you tend to get these little westerly wind bursts that come out. And what that does is that helps invigorate the position and strength of the jet stream here, especially in winter, to really get it cranking. And you know this, right? We saw that all winter long. That's what kept things mild, because we had the strong subtropical component of the jet. I showed you at times it was moving 200 to 250 miles an hour. So this is why we care. It's about redistributing momentum, taking it from the tropics and giving it to the poles or the mid-latitudes, or vice versa. Okay, so that's why we care. Now, what are the models saying? Well, remember, the CFSv2, going from March, April, May to April, May, June, you can kind of see the progression to May, June, July. Already by May, June, July, look at the strength of the La Nina it's producing. And if you don't mind, go from May, June, July right over to this graphic, which is August, September, October. And it's not just got a full-blown La Nina. Like, it's got an epic La Nina developing, and at the same time, colder water showing up in the Gulf of Alaska, and very warm water here in the Atlantic main development region for hurricanes. So this is trying to take us not just to another extreme, but this is trying to produce like 1988 levels of drought in the midsection of the country. It's going to keep the West cooler. It's going to keep the West unsettled. It's probably going to keep the East wetter, but in the middle part of the country, this is given a massive omega block, sending storms over the top of it way up into Canada. And then capping off the season with what we could probably estimate to be 150 to 200% of average on a hurricane season. And that's just one model, but we have to consider it. And this is what the precipitation looks like. So March, April, May, it's drier in the upper Midwest. It's drier in the Northwest, but wetter from Colorado down into the Southeast. This is April, May, June. Just take a look at the graphic. May, June, July. Now, what is it starting to do at that point in May, June, July? Bringing up dry conditions here, such that let's just go over to this map, by July, August, September, it's building into the Western Corn Belt, and by August, September, October, full-on massive blocking ridge with storms running the periphery. And that's what the model's been going after. It's been trying to just absolutely bake and dry out the central part of the United States. Now, we say all of that and then remind ourselves that we have not yet crossed the spring predictability barrier, and this model is the most aggressive of all of them. You need a reminder, it's this one down here. So what else do we have in order to do these comparisons? Well, we have the European model, which you saw a few moments ago. That's the one that has a much slower progression. This is the only new one that's been released. I'll get new NMME data later this week, and then in the middle of the month, the Climate Prediction Center will update their stuff, and we'll just keep the cadence going. So now let's watch. April, that's where we are. There's the cooler water beginning to show up as we transition to INSO neutral. There's May, June, July, August, and September. Now understand something. These color bars are different. So this one goes all the way to 9 degrees, 9.5 degrees, whereas this one only goes down to 4. Got it? So we have to be very careful when you look at this to assess the size difference in the INSO strength. But still, we're looking at ocean temperatures here that are somewhere in this color range, right? So we're right in through here about a degree cooler than average, not 3 degrees cooler than average. Then take note of the warmer Atlantic. That is still a case. But the warm water that's pushing into this area seems to be closer to the west coast than the other models. And I want you to see what that does. So we walk through the CFSv2. Here is what if we come into the United States, we look at the precipitation. We'll do this on a seasonal basis. Let me take you back. It's almost the same as where it was a month ago. That's the March, April, May outlook. This is the April, May, June. Just like in the previous run, it's trying to bring drier conditions out of Mexico into Texas, New Mexico, up the high plains is what it's got. This has got a lot of people that like to storm chase, thinking about a very active spring in terms of severe weather. And if we end up getting a pretty invigorated jet, we could push that dry line out farther to the east. Now, this is no good if you're in the high plains. We've already watched acreage burn here, and we know that it's quite dry in this area. We've been talking about it for months, right? I've been worried about that. And if you end up getting stronger winds in the jet stream, that will translate into stronger winds coming off of the mesa and the caprock and coming off of this area and just blasting out into the plains, setting up our severe weather threat farther to the east. That is a possibility. What about May, June, July? And then June, July, August. The model's trying to carve out a path where it says if you are west of that line, your risk increases. And if you're east of that line, it doesn't. What a different solution compared to the CFSv2. And this is July, August, September. Now, does the European model crank up a hurricane season? It does. But it's got the driest and hottest conditions in the Great Basin, the Four Corner States, the Western Plains, and not in the eastern half of the United States. It's just another model. We just have to look at it. So can I do this another way? We've got a good record on El Nino and La Nina events. Now, this does not take into consideration what's going on in the North Pacific. But if we use all of our El Nino events and say, well, what happened during those years? You get this. Just put them all together. This is what you get. Now, I'm basing this, again, there's all the years, March to May, and I'm basing it off the 1981 to 2010 climatology years. So I'm doing that because a lot of these years are pre-2016, just as an example. So we were in March through May, wetter here, a little drier in parts of the Ohio Valley, drier in the Midwest, upper Midwest, which meant decent planting windows opened up. And we were wetter here in California still, but drier in the Northwest. May through July, you look at these numbers and you say probably the greatest risk of drought was down here in the mid-south over toward the western and high southern plains. This is not alarming in this area. A little bit drier in New England out of this as well. This is the historical analogs. In fact, if you just put them all together, this is what I would conclude. If I just had to put a stamp on what a composite map of every single year where El Nino peaked around Christmas and transitioned to neutral conditions in spring and maybe La Nina by fall, we just tended to be greater risk of drought here. And this isn't useful. I mean, I could tell you this all day long, but if you actually saw the individual years, they all had a different flavor. And making this prediction right now is silly. But we do it anyway because we try to look out there as far as we can. but I want you to know that if I had to put them all together, this is what I'd get. Now, I always get asked, well, is there any year that's close to this year? And I'd say that 2016 is probably our closest year to this year. And this is what the ocean temperatures look like on March the 4th. So here they are now. Here they are on March the 4th in 2016. Now, the arrival of the cooler water happened later. It didn't really get there to about mid-May. But that's how things transitioned in 2016. We had a warm Atlantic, but notice this. This whole region, Gulf of Alaska, coming off the Baja of California and off California, was quite warm. And that was one of the main reasons why the precipitation pattern in spring was quite wet through the plains. A little bit drier, open windows in the Midwest, drier in the Mid-South, drier in New England, drier in the Northwest. And when you go from April to May, and instead let's flip this over now to look, let's go June all the way to September. This is how the rest of that year panned out in terms of precipitation. Hopefully it'll get going here for you in a second. There it is. You see, overall, we had a wet finish to the season in the Midwest, upper Midwest, Great Lakes. The drought area was down here in the south and southeast. And what happened in this particular year was we had ridging down here. So storms rode the ridge all summer long like this. This year, I'm concerned that maybe it's not here where the ridge lives, but there. And if it's there, they still ride the ridge and go over the top like this. That puts Texas and Oklahoma and Arkansas and Louisiana and New Mexico and Kansas and Colorado into a very vulnerable spot for this year. Now, after you've heard me put all of that together, you have to have a full confession here about how this works, okay? I'm going to show you this. When you're looking across the top of this slide, I want you to understand that there have been hundreds of billions, probably close to $1 trillion spent over the last 50 plus years in trying to do this kind of weather forecasting. This is the European model solution. This is the National Multi-Model Ensemble, which combines 8 different models. And this is the U.S. government's forecast, taking all of this into consideration. And what are we looking at? This was the forecast from last March, okay, March 2023, for April, May, June. Now, you just sit and look at that for a second. I showed you this a year ago, and I validated, I made a case for it. I felt like I had confidence in this. I went to every meeting going, I think we're going to have tighter windows in the Midwest. I think if there's drought issues, it's in the north, it's in Canada. That's what I said. And this is what happened. It wasn't until about May the 8th that I think I started to figure out this pattern had lost the Bermuda high and that we were going to go drier. So I just want to let you know something here. These models and their ability to do long-range prediction, well, sometimes we fail. And what happened last year? We transitioned out of 3 years of La Nina into El Nino. And that transition time period looked like this by the time I got to July. Now, here's the point to think about. This was the beginning of last year's El Nino developing in July. But what it had to overcome was the cold water here. And just as a reminder to everyone across North America, the cold water here, when combined with the cold water there, if it shows up, is a major drought signal for this whole region. Okay? What happened last year? We had cold water here early, cold water here that lasted till July. But by July, all of this moved in. You say, well, what did that do? That changed the whole jet stream pattern in July into August, driving northwest flow, which had storms that rode over a ridge that started up over Mississippi to Texas. Remember how hot and dry it got in Mississippi and Texas last summer? And that put all of those storms right over the top of it, which brought rain into the Corn Belt. So 50 days of nothing, and then 45 days of really routine rains. So just a reminder how quickly these things can change. Okay, that's it. That's what I know. We'll add to that when we get new data in, but I need you to see my latest thoughts. Now, let's get into the near-term forecast. This is a long video. Look at this low. I love every bit about this. This thing came through. It delivered quite a bit of wet weather. And yesterday, take a look at how it transitioned forward. Storms on the backside. Got to see the snow up here in the north. And that low is going to curl up the east coast, following the one that started 2 days ago on Cape Hatteras that's rolling right up here right now. And it delivered some precip. This is what we got out of this. We needed every drop in this section. And we're setting up, for now, a very wet next 10 days to 15 days here. The west, you're going to finally get a break. A much-needed break in this pattern. And this is what we've got early this morning on our all hazards weather map. So high winds here, issue with being quite dry, so we're going to have to be on the lookout for some fire weather watch in this region. Down south, we have dense fog, and just a couple of places where we've got winter weather advisories, and those are there because of the system that's rolling through. Now, the severe storm threat today versus tomorrow, and then getting into Friday, looks something like this. So watch the south and then the Gulf Coast as we progress toward the later end of this week. You can see these two maps. Just go to agweather.com, click on these severe weather metrics here, and you'll be able to see these graphics, or go to spc.com and get them yourself. But this is what's going to take place. The high-res NAM brings that snow through the northern plains and right up here into the southern Canadian prairie. There's that front we talked about yesterday dropping down with some snow, while all of this really wet weather curls up through New England today. I love that. Let's bring all that moisture in. And the reason why is because, don't forget, we're quite dry in this area. Oh shoot, which tab was that? There we go. So as that takes place, we'll have one system leave and the next one emerge out of the Rocky Mountains here by Thursday. Now this is where we get into the risk area, right in through here, of the strong to severe storms. And you can see that on the back side of it, there's going to be enough cold air to bring snow into Colorado, out of western parts of Nebraska, in Wyoming, and it may dip down into the panhandles briefly right here with some pretty intense snow showers by the time we get out there to the 8th. But this system is slow. I mean, really slow. And we need it to be slow because it's what's going to help deliver the moisture. Now, I was reading through the comments yesterday, and people were saying, when are you going to put the AI stuff on ag weather? I'm going through I'm excited about this pretty amazing renovation of my website. It'll have everything it's had, but I will put all the AI stuff on there very soon. I'm also developing a new setup using a new technique to give all these point forecast data. I'm really excited. I'll just show it to you later. But this is the new AI forecast out 10 days. And what's changed? This has changed. That's an area now that's seen improvement in moisture. Still very wet here, still wet up the East Coast, still wet along the coast of the West Coast, excuse me. This is our drier spot, and drier down here in western Texas. But that's a change right in that area. So how it gets there is this. We've got the GFS on the left, the European on the right. We've already watched through that system. Now keep your eye on the Central Plains. So this is Friday, getting into Saturday, and Sunday as that low curls up. So we have the severe weather threat on Thursday in the southern plains, along the Gulf Coast on Friday. The low curls up into New England on Saturday, Sunday, mainly Sunday. And as it does so, we have the snow on the backside, which we're going to have to assess where that's going to be in a few moments. But I love the model agreement now. That's out 5 days, and we're looking pretty solid. Next low comes into the northwest. That's what's providing all that west coast rainfall. And the Midwest gets a break into early next week. And what we start to watch for is the pattern to give us one more good push out there around the 14th, as that's when the pattern does this. And there's the low going across the south. This is when the ridge starts to build into the west. So let's have a look at the total precipitation. Let's blow this up a bit. Here's 1 week's worth of precip from the dynamical European model, not the AI version. Let's compare that to the GFS. GFS has got a much wetter stripe right in through here, as you can see, compared to the model, compared to the European. And on the snowfall side of it, here, this is the European model solution for the next 7 days. There it is. And here's the GFS. Now, I like the agreement we now see in New England between the models. I'm so sorry. That's the European, that's the GFS. But the GFS has got much more snow on the backside of this, which is a hard sell for me right now, seeing the way the pattern's going to be. But let's take it over to the ensemble side and get a good look. European ensemble, best chance at 1 inch over the next 10 days. This is the best chance at 3 inches over the next 10 days. And again, look at that coming out there now. And the Canadian Prairie as well, and New England. Here's 6 inches, 12, and 18. On the drier side of this, there's that corridor we're watching, and here's western Texas, New Mexico. That's it. Wetter side of this forecast, here's the best chance at getting over 1 inch, wettest in the southeast and along the west coast. There is the chance of getting 2 inches, and here's the chance of getting 4. So we've already had some of this. That's why the 4 number backed off from the previous run. Okay, let's get toward the end of this now. I told you that by the time we get to day 10, the model's been very consistent with that look, which sends that low across the south. You know what this also does? That keeps that region wettest. And then we get out there past the 17th, 18th, 19th, and and we head into Easter week with a lot of cooler air here and a lot of warmer weather to the west. So what does that mean? That ridge means we're going to see drier conditions in the west. It's in all three models now, wetter along the south, maybe into the plains as well. That's what you got. That's that last system coming out there on the 15th that we're watching to deliver more moisture into this area. Temperature side of it. Today, another very warm one. We're going to see this pattern on repeat for a little while longer, but we're going to get rid of the chances of these 70-degree days here by next Monday into Tuesday. So I'm sorry, I kind of walked through that fast. That's Wednesdays today, Thursday tomorrow. There's Friday. Look at that. Coming forward into the weekend. This is when the low curls up through the Ohio Valley, rolls into New England on Sunday, and behind it already a big warm-up happening. But that day 5 through 10 time frame is kind of the last of this because the day 10 through 15 starts to cool it off as the ridge builds west, and that is echoed in both models. See the ridging here? Cooler air arriving back into this area. That leaves us with one last place to talk about, and that is South America. Temperatures are really starting to come up in Brazil. This is the next 5 days. This is day 5 through 10. And what's important about that is that the 10-day forecast, which I'm going to show it to you, continues to show these drier conditions in Brazil's center-west growing area with a lot of storms in Argentina. Decent moisture in southern Brazil, northeastern Brazil, but that's the drier spot. Now, I meant to get more time to study when I think this could break down because the models want to do this. They've got dry conditions for a lot of March, but they're trying to bring in April rain. And if it does, that is going to really, really help out this safrinha corn crop. But I still think there is a failure mode on this. I really do. I think that the MJO, remember we talked about it all week, the MJO may not make it into the West Pacific. And if it returns to phase 4 and 5, that's a dry signal here. That'll be what I'll be looking at and studying for the rest of the week. From there, though, I do need you to know that the March, April, May seasonal forecast just released, we did this for the U.S. at the beginning of this video, looks like this, and that's the April, May, June, meaning that this safrinha crop could struggle for late season moisture. And by the way, as much as the U.S. model, the CFSv2, and the European model, the ECMWF, disagree for North America, they both at least agree that this March, April, May timeframe could be risky in terms of being dry here as we go into that fall time period for South America. So I got to watch that carefully. All right, I'm done. Thank you so much for listening. This was a long one, but we had big stuff to cover today. I will catch up with you in the morning. I'll be in Kansas tomorrow. Thanks.